Let us look at search methods in an array. There are two search methods. One is linear search and the second one is binary search. So in this video we'll look at linear search, and in the next video we will talk about binary search. So let us look at linear search. Here I have a list of elements. I have taken a list size or array size as 10 and the list size is also 10. Now here I have taken unique elements. So for performing search, the elements must be unique. There should not be any duplicate elements. If there are multiple copies, then if you are searching, we may be getting any one of the copy. May not be able to reach another copy of it. So there should be unique set of elements. Then in a list, if I want to search for any key element, so the value that we are searching, usually we call it as key. So suppose I am searching for a key that is 5. Let us look at linear search method. In linear search, we search for the key in a list linearly by checking the elements one by one. For searching 5, we will start comparing from first element onward. Is it 5? No. Next, go to the next element. Is it 5? No. Go to the next element. Is it 5? No. 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 Yes, it is found here. We already know the element that we are looking for, that is 5, and we want to know where it is present. So we got the index, that is 7. So usually the result of a search is the location where the element is found, so that we can access that element. Now let us take one more key element and search it. So this time I'll take the key element. Key is 12. Let us find out whether 12 is present or not. So we'll follow the same procedure. We'll start from the very first element in the list and compare 12. Is it 12? No. Go to the next element. Is it 12? No. Go to the next element. The next, and even this is not 12, this is not 12, then we have reached the end of a list. So if we have reached the end of a list, means element is not found. If the element is not found, search is unsuccessful. So if the key element is found, we say search is successful. If it is not found, then we say it is unsuccessful. So this is successful. This is unsuccessful. So key element is found, this search was successful. Key element is not found, so this search was unsuccessful. So when you are searching, you have to take care of both the things, whether the element is found or not found. Now let us write a pseudocode for performing linear search. So for searching for a key element, we start comparing the element from the 0th index onwards, and every time we move on to the next element. So it is just like traversing a list. This can be done using for loop, or even if you want, you can use while loop. So I'll first show using for loop. So for I start from index 0. So I should start from index 0, and till where I should go, till the end of a list, and the index is 9. So that is length. Length is 10. So it is length minus 1. So I can say I less than length. So I should traverse the whole length of a list, and every time I should be moving forward. So I plus plus. Then what I have to do? Every time wherever I is, I should check that if the key element is equal to A of I. So if key is equal to A of I, if it is equal, then search is successful. So we got the element. So once you got the element, what we want the index where the element is found. So here we can say return index. So who is giving index? I. So wherever I is present, that is index. Return I. That's all. So let us see how it works. I is initially 0. Suppose the key value that I am looking for is 5. Then it will check I is less than length. Yes. Key, is it equal to A of I? That is key 5. Is it equal to A of 0? 8? No. So it will continue and say I plus plus. I will move to the next index. Then here it checks key, is it equal to A of I? 5, is it equal to A of I? That is A of 1? 9. No. So it will go to the next. So it will continue. And once it reaches here, now this time key is equal to A of I. Yes, 5 is equal to A of 7. Then return 7. So this is in case of successful search. Now what happens in case of unsuccessful search? Let us see. Initially I is 0. Suppose we are searching for 12. First it will check that key is equals to a of 0. 12, is it equal to this one? No. Then I will move to the next element. Then check key is equal to a of 1. A of 1? No. Then again I plus plus, I moves to the next element. Then again check 12, is it equal to a of this? No. So in this way it will continue and this condition will never be true. So I will move to next, then next, then next, then finally let us take this. I is less than length. Yes, length is a 10 and I is 9. Yes, it is less. So key, is it equal to a of I? 12, is it equal to 2? No. Then continue I plus plus. I will move to the next location. Now I became actually 10. This I became 10 and 10 is not less than 10. So it will come out of the loop. So if it is not finding a key element, then it will come out of the loop. If at all key element is found, then it will return, means stop the procedure here itself. So if the key element is not found, then it will come out of the loop. Then outside the loop we can say return. Now if the key element is not found, then we have to return something to show that element is not found. So the invalid index, that is -1. So we can return -1. So usually we do it like this. If the element is not found, then return index is -1. So if you are calling this procedure, then if you got -1 means element is not found. If you got a valid index means element is found. So that's how you can know whether the search was successful or unsuccessful. So this is about linear search. Let us analyze, find out the time complexity of linear search. So one thing I will tell you about time complexity. So for finding the time complexity, either you can observe the work that is done or else you can read the code. So let us see from the procedure.